Good evening, ladies and gentlemen. Nice little paying gig coming through the shop today. Agitation tank bushings. Inside the agitation tank there's a paddle. The end of the paddle has a tail shaft. The tail shaft rides inside this bushing. That's a blind hole through the bushing. You can see here in the section view. Blind hole. Two other holes that retain the bushing in the bottom of the tank. Our outside dimensions are 2 1/8 square. Here's our stock. It is 2 1/4 square. So we'll have to deal with that. We will cut our stock down to size for starters. We need an finished length of 2 inches. So I've got Grandpa's knife here. We'll go a little long and clean it up afterwards. If you push really hard, there we go. Did I mention we have 3 to do? Anyway, new blade, Stanley, number 1299. Works like a charm. Next thing we got to do, we will, these are sit 2 inches tall. We'll go over to the forejaw and turn them to 2 inches. We'll see at the lathe. It's from UHMW. Did I mention that? Ultra high molecular weight. Okay, we've got it in the forejaw. We're roughly centered. We're just facing, so centering it is not terribly important. We'll clean up this face. That did not quite clean up. We will make another pass. I've got my magnetic back dial indicator on the carriage. I'll advance. We'll take another 10 thou off. Lock the carriage. I'll bring you back when we're finished this pass. Lucky you. That looks good, all cleaned up. So we'll flip it over and face it down to 2 inches deep. I'll bring you back. We're at 38 thousandths over. I'll take that in one pass using my magnetic back dial indicator. There, the indicator is zeroed. We'll advance the carriage 38 thousandths. Lock the carriage. Here we go. That'll do. One down. I'll bring you back when we have all 3 to flies off. That was 30 thou pass. So all of our pieces now are to length. Our stock is 2 1/4 square. We need it 2 1/8 square. So just the same, more of the same process, facing down to size. I'll bring you back when we're closer. Okay, we have our stock all turned to size. Turning it on the lathe was great fun, but of course if you want to work fast, the mill would be the way to go. Leave your stock together, get yourself a 6-inch length of stock, and use a face mill, bring it down to size. So now we will work on this blind hole. We'll again do it in the forejaw. We'd like a nice flat bottom on the blind hole, so we'll use an end mill and finish up with a boring bar. I changed my mind. We'll go with a Forstner bit rather than an end mill. This is 1 inch. We'll give it a nice flat bottom hole. The little pip in the middle doesn't matter. We get a nice flat bottom hole, and then we can take it to size with the boring bar. Let's get these centers marked up. The paddle that rides in this bushing is quite slow RPM, like 45, I believe. So it's not like a high-speed deal. Precision is not too critical. Let's go over to the forejaw. So here's the setup. I have this scribe point in the tailstock chuck. We've used the forejaws and got everything lined up nicely. Looks like we're nicely centered there. So now we will commence with our drilling. I want to show you how we're going to control the depth of this drilling operation. I have a collar fixed to the tailstock quill. I have an adjustable parallel set for 1 1/8 inch. That's the depth we're looking for. So as I'm drilling, it's, again, everything is not critical on this hole, but once this slips in there, I know I'm pretty darn close to 1 1/8 inch. That's how we'll set up the depth of this drilling operation. Okay, we've just started to cut there, so now I will, in essence, zero my collar here against the tailstock. Now we just keep drilling until this fits in there. There we go, our adjustable parallel just fell in there now. There we go. Nice smooth walls. Nice flat bottom. Okay, well, while we have this centered, we'll do our boring. So I'm going to bring the boring bar to the bottom of the hole and set my carriage stop. Nice smooth wall. That's a nice fit for the shaft. So I've set my cross slide dial to 0 so that we can repeat that cut. Okay, we've got our nice flat bottom holes in all 3 pieces. We've got a good fit on the shaft. Next, we're going to turn our attention to these chamfers on the corner. We'll do that on the milling machine, and there's our weapon of choice. We'll slide over to the mill. Okay, here we are at the mill. Our work is in the vise. There's a parallel on the bottom of the vise jaws. I've used my 45-degree angle gauge to set the work up. We'll find the top of the work using the, we'll lower until we find the top, and then we'll drop 200 thou. Okay, 0 my zoom axis. That was 100. I think I'll go just a little bit more. 125. Now we have to re-find our top. Since we're sitting on one of the flats that we just cut. We'll find that top again and drop 125 again. There we go. That's worked very nicely. 4 consistent chamfers. I'll do the other 2 and bring you back. Okay, there we are. We have nice chamfers on all 3 bushings now. There's metal, 3-sided metal strap that gets welded to the bottom of the tank. Strap on this side, strap on this side. We're going to put holes through, and cotter pins go through the metal straps. This is a high wear item, so they get replaced often, hence the cotter pins. That's the whole idea of these chamfers too, is these metal straps have a radius on the inside. So that's for clearance. Next job is to put those 2 holes in. I'll bring you back when I'm set up. Alright, our next operation is 2 7/32 holes, 1.25 inches apart. Back to the mill. Okay, we have a parallel under the work. The hole for our bushing is on the top here, so our 2 holes are going on the bottom. We have a stop set up. We have our ball bearing edge finder in the chuck. We're going to find center on the x-axis. There's that stroboscopic effect on the x-axis. Full disclosure, I forgot to hit record last time, so I just came back up against here again. My DRO was showing 4/10, so we're within 4/10 of where we were last time. Pop over to the other side. No power feed on this girl. Right there, I'm getting the stroboscopic effect. X 1/2. So right there is the center of our x-axis. Now we'll find this edge. Ball bearing edge finder kits are available at my store, link in the description. That center line of the center axis of the spindle is now exactly 0.4331 . Just doing my sanity check with my pointer. We're looking real good. 7:30 seconds drill. Hold on. So the hole goes at 0.625 in the Y. There, I'll lock my Y now. And 0.625 each side of center in the x-axis. Here we go. Just like butter. And 0.625 the other side of center. 1.25 inch spread. We just put a little chamfer on those. Little chamfer with our Noga this here. Maybe a tiny bit more deburring, but I'll see if I can wash it up. This stuff is very susceptible to getting dirty, greasy. But there we have a finished product. Because we use the stop and the y-axis is locked, I can pop in my other two pieces real quick and do them up. I'll bring you back when we're done. There, we'll give those a wash with soap and water. Hopefully they clean up a bit. This was part of a 4-part gig. The bushings are 1 part. This is the tail shaft for the paddle. Here's the drive shaft, 14 inches long, 1045 steel. Couple of holes 90 degrees apart. Nice radius in the transition there. Keyway. That was part 3. And part 4 I haven't started yet. Watch for a video coming soon. This is the jig. The guys, there's a hole in the bottom of the tank where this bushing gets mounted, where the straps that hold this bushing get mounted, I should say. So this is a weld jig. The guys put this pin in the hole. They put their straps around this jig and weld it up. A round recess here so that they don't end up welding the jig itself. There's our stock to make this jig. Coming soon to a video near you. Anyway guys, thanks for hanging in there. This was a lot of fun. Hope you enjoyed. Hope you might have found something useful. Check out my store. Lots of cool kits. Link in the description. Thanks for watching.